So one thing they did, because it was so easy to measure kinetic energy of electrons, is plot the frequency of the light against the kinetic energy of the electron that's coming off here. And in your notes and on these slides here, just for your reference, I'm just pointing out what's going to be predicted from classical physics. You're not responsible for that, and we won't really discuss it, but it just gives you the contrast of the surprise that comes up when people make these observations. And the first observation was that the frequency of the light had a linear relationship to the kinetic energy of the electrons that are ejected here. This made no sense at all to people, and again, they saw this effect where if you were below that threshold frequency, you saw nothing at all. So that was frequency with kinetic energy. The next thing that they wanted to look at was the actual intensity of the light and see what the relationship of intensity to kinetic energy is. So what we would expect is that there is a relationship between intensity and kinetic energy, because it was understood that however intense the light was, if you had a more intense light, it was a higher energy light beam. So that should mean that the energy that's transferred to the electron should be greater, but that's not what you saw at all. And what you saw is that if you kept the frequency constant, there was absolutely no change in the kinetic energy of the electrons, no matter how high up you had the intensity of the light go. You could keep increasing the intensity, and nothing was going to happen.